Now we will discuss the last part of hybridization, that is the types of hybridization. Already we have discussed what is hybridization, that means the basic concept hybridization and the essential conditions required for hybridization, characteristics of hybridization. Already we have discussed in details. Now we discuss the types of hybridization. The hybridization, the types of hybridization can be divided into two parts. The first part, hybridization involving only s and p orbitals. The hybridizations involving s and p orbitals, and second part, the orbitals involving d, s and p orbitals. Orbitals involving d, s and p orbitals. Therefore, on the basis of types of orbital, we can divide hybridization into two categories, that is sp hybridization and dsp hybridization. First, discuss sp hybridization. First, your sp3 hybridization. We know that sp3 hybridization is formed when one s orbital and three p orbitals are hybridized. P orbital means px, py, pz orbitals are hybridized. We get 4 sp3 hybrid orbitals. We get 4 sp3 hybrid orbitals. This is our structural diagram of s orbital, and this is your 3p orbitals, px, py, pz, and this is the shape of hybrid sp3 hybrid orbitals. The shape of sp3 hybrid is tetrahedral, that is tetrahedral, and bond angle is 109.28 degree. 109.28 degree. The percentage of character, as you know that the sp3 hybridization involves the total 4 orbitals. If we 4 orbitals count 100%, then percentage of s character is 25% and the percentage of p character is 75%. That means sp3 hybridization contains s character 25% and p character 75%. And the best example of sp3 hybridization is your alkane, water, ammonia, etc. These are come under sp3 hybridization. Let us discuss sp2 hybridization. sp2 hybridization. It means that when s orbital and 2p orbitals are hybridized. 2p orbital means 2px and 2py orbital are hybridized. We get 3 sp3 hybrid orbitals. 3 sp2 hybrid orbitals. 3 sp2 hybrid orbitals. This is the orbital representation sp orbitals. This is the s orbital. This is the px and py orbital intermixed. We get, this is the sp3 hybrid orbital. sp2 hybrid orbitals. sp2 hybrid orbitals. The shape of sp2 hybrid orbital is a triangular planar. That means a triangle. The shape of sp2 hybrid orbital is a triangular planar, means the 3 orbitals lie in one plane. Triangular planar means a triangle in which the 3 orbitals lie in same plane, and bond angle is 120 degree. Bond angle 120 degree. The best example of sp2 hybridization is alkene, BCl3, etc. Let us discuss sp hybridization. sp hybridization means when s orbital and 1 p orbital are hybridized, we get 2 sp hybrid orbitals. 1 p orbital means it may be px, it may be py, it may be pz. In conventionally, we take px orbital, that is s orbital and px orbital are hybridized, we get 2 sp hybrid orbitals. This is the orbital representation. This is s orbital, this is px orbital, and this is the shape of your sp hybrid orbital. sp hybrid orbital. The shape of sp hybrid is linear and bond angle is 180 degree. The best example of is alkyne, carbon dioxide, etc. This is the types of orbitals involving s and p orbitals. That is sp3 example is alkane, sp2 is alkene, and sp3 is your alkane, sp2 is your alkene, and sp is your alkyne. Very common example. Let us discuss the second type of hybridization. Second type, the hybridization involving the participation of d orbitals. The hybridization involving the participation of d orbitals. That means it may be d2sp3, d2sp3 hybridization, dsp3 hybridization, dsp2 hybridization. dsp3 hybridization means when two d orbitals means two d axial orbitals, that is d x square minus y square, dz orbital participate in hybridization with s orbital and 3p orbitals. We get 6 d2 sp3 hybrid orbitals. We get 6 d2 sp3 hybrid orbitals. sp3 hybrid orbital. This is your orbital representation. That is s orbital and 2 d axial orbital, that is d x square minus y square and dz square, and 3p orbitals. Why axial orbitals participate? It is already we have discussed. The orientation of the hybridizing orbital must be same. Already we have discussed in details the orientation of the hybridizing orbital must be same. Here the participation of axial orbital 2d axial orbital is required because the orientation of dx square minus y square and dz square orbital is same as of your p orbitals, same of px, py and pz orbital. Therefore, these two axial orbitals involved in the hybridization process, and the shape of d2 sp3 hybridization is your octahedral. Shape is your octahedral. This is your octahedral shape. This is your octahedral, and one atom is above the plane and one is below the plane, and four orbitals are the four corners of the square planar. This is the shape of octahedral hybridization. The d2 sp3 hybridization. Then come your dsp3 hybridization. dsp3 hybridization means one d orbital, that is it may be dz square or dx square minus y square orbital participate with 3 p orbitals and 1 s orbital. We get 5 d2 sp3 hybrid orbital. We get 5 d2 sp3 hybrid orbitals, and the shape of d2 sp3 hybrid orbital is your triangular planar. This is the triangular planar shape. This is your triangular planar shape. This is your triangular planar shape. This shape is triangular planar. And let us discuss the shape of dsp2 hybridization. In dsp2 hybridization, that is 1d axial orbital, s orbital, and 2p orbitals. 2p orbitals are hybridized. We get 4 dsp2 hybrid orbitals. 4 sp2d sp2 hybrid orbitals, and the shape of dsp2 hybrid orbital is your square planar. Your shape is square planar. This is the square planar shape. These are the hybridations involving the participation of d orbitals. This is we discuss in details the types of hybridization. First category involves the participation of only s and p orbitals. Second category involves the participation of d axial d orbitals and s and p orbitals. This is the all about the types of hybridization and structure of the compound. This completes the process of hybridization. Thanks.